Hello everybody. My name is Giovanni, and thank you very much, George, for the intro. I don't think it's as radical as it's putting it, that you don't need a graph database. No way. In fact, the reason why we wanted to sponsor here is because after 2-3 years of doing this on top of your existing backends, so most of what you're going to see here works on top of Oracle, works on top of Postgres, Elasticsearch, other backends. We connect. This year, we started to invest considerably in graph databases. So we have launched the connector to Neo4j, and you are going to hear about connectors directly to other graph databases, because only graph databases can do certain things that a lot of use cases need, right? So that's why we're here. However, what we're claiming here, and you'll see now, is that if you have a petabyte of data in your enterprises, and I was talking yesterday with some friend of mine that works at MasterCard, and he says it's actually 15 petabytes. And then you're not going to put them in graph databases ever, right? Maybe in 50 years. So, but you still want to see it as a knowledge graph. You still want to connect all the dots if you want to catch the bad guys, right? So how do you achieve that, right? And the answer is a polyglot system, is an analytics system that can actually show you everything as a graph without you necessarily immediately have everything in a graph database. So that's what we're discussing here. What is augmented analytics? And I hope that some ideas are actually interesting to you, because this is a new terminology. So let me actually show you that and how you get a petabyte knowledge graph in your backends already. So who am I? Known George for 15 years. We've been working on RDF and Sparkle. I was so excited about 2002, working on RDF and doing all sorts of crazy things. Since a long time. In 2015, we have taken some of the ideas that were some of the most exciting about how do you browse a knowledge graph? How do you actually interact with it? So say that you have billions and billions of edges. Do you really want to see everything? Do you really want to see everything as a click, 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 click? I want to expand the graph. I want to expand the node. How many nodes can you see? Is that really how people want to see information? That was big point for us. We devised prototypes together with some people of a modern new way to browse modern graphs, which would basically complement the link analysis, but in a different way, called relational navigation, relational set-to-set navigation. And that's what we're going to show you. So in 2015, we started building from scratch this new concept. We got about 10 million of funding from American and European investors. The main company at the moment is 40 people with offices in Ireland, in Galway, in Dublin, in France, in Italy, and in the US. So we serve knowledge graph investigators. So our users are not using knowledge graph for like information integration for maybe applications or something like that. Typically, they really want to investigate the data. They want to understand who is the bad guy. Is there a cybersecurity attack? Is there something broken in my company? So it's really about serving an investigator, like how do we serve a user analyzing this knowledge graph. So it's IT monitoring and discovering, law enforcement, intelligence. We work with a lot with intelligence. Crime and finance here in London, knowledge graph discovery in life science, and then with a lot of partners and system integrators. So what is augmented analytics? This is a term by Gartner. Like if you Google it up, augmented analytics is a Gartner term. Now, Gartner, if you read those definitions, it's a bit fluffy, right? Says it's analytics, it's the modern analytics, which has a lot of AI, right? Now let's make it a little bit more concrete. What can that mean in practice? And what you're going to see today, we think it really fits in there, because it's basically, if you think Tableau as an analytics software, you get your pie chart and your histograms, then what is a modern version of that? What is the next step? Well, we're saying it's when you mix knowledge graph and analytics, imagine a Tableau that, however, is knowledge graph aware, and it allows you to browse and see how things are connected. So you have link analysis, analytics, but you also have search engines. You also have the unstructured data, the text, the messages, the news. But you also have the machine learning telling you anomalies on the fly, telling you that two records, they should actually be the same because they talk about the same person. So as everything should be connected. So that's not what typical analytic does, and that's what augmented analytic is doing. So augmented by knowledge graph, augmented by search engines, augmented by machine learning and other AI. And there's many forms of AI that can help analytics. Like I said, entity resolution, matching records, anomaly detection, etc. And then imagine operational augmented analytics. So that on top of live data, on top of your streams, your clicks, your customers. That's what we are building. So if you think of your Tableau as your typical BI, if you think about then people have seen it very separated from a system like Splunk or Elasticsearch. And they've seen it very separated for a system like link analysis and knowledge graph. So knowledge graph and operational data has been seen as completely two different things, right? But that's what we're trying to break down and say, no, it's really the same thing. It's your enterprise knowledge graph that you want to put together. So that's what we're proposing. That's architecture that we built. You connect to your data where it is. So I put Elasticsearch very big here, and maybe it's not very popular here in this audience. I don't know, like just curious. You guys know Elasticsearch? Whoever heard of Elasticsearch? Very good. I mean, we have about 20–30% of people, which is because it's a very technical system. But a lot of people use it because you can store terabytes and petabytes of information inside there. Streams, clicks, logs, messages, everything can go inside Elasticsearch. I have customers that have 150 nodes, a cluster of 150 Elasticsearch nodes full of stuff. So that's what people use for big data, right? But then they also use Spark and Hadoop, of course. And then SQL, like your Postgres, your Oracle system, but also GraphDBs, Neo4j, connectors, Stardog, and others are coming now. We're working with people, and your REST APIs. So you connect to all this system at the same time. You try to leave data there. You try not to move data from there. So you try to just talk to them, but not really copy somewhere else. You use a data model to describe how your data is interconnected. So maybe there is a customer here which has a lot of logs here and has a lot of emails in the search engine, but they have the same ID, so you describe it in your data model, and then you drive the entire analytic and investigative experience. You can go from the search engine to the dashboard all the way to the link analysis system. Sorry, it's a bit small from there, but you will see soon. So that's the concept. Connect to the data where it is, and then give investigators. So Elasticsearch, for whoever doesn't know, it's cluster scalable, 500 billion documents, petabyte of data, and that's where the petabyte knowledge graph comes. It can real-time semi-structure, which means you can take text and different structures. It's very fast for search, aggregates, drill down. It does fuzzy searching, so ranking. So is it perfect for knowledge discovery? Not really, but it's an awesome start. And that's our technology. So when we say Elasticsearch, we use it a lot. It means that you can use the one you already have in your enterprise, but you add one plugin that we have developed. And this is a little bit of the secret sauce. Because Elasticsearch, it's typically just a search engine, but our plugin adds join capabilities. And joins are absolutely crucial in knowledge graph use cases because you want to join effectively different records at scale. So it doesn't become really a graph database, but it can do a lot, and you will see later. So what you're going to see, it's not really pure Elasticsearch, but it's also Elasticsearch supercharged. But we also connect directly, so no ETL, to different backends, including graph databases and Fire queries over there. So I call it the mixed petabyte knowledge graph. Let me explain a little bit what I mean by this. In your organization, you certainly have a lot of high volume big data, security logs, application logs, network event, web traffic, call center. And this is stuff that you don't, like I said, you don't want to put in a knowledge graph typically. So you put it in Elasticsearch, you put it in Spark. But they're all connected, right? I mean, they form a knowledge graph. Here you might have an application, a security event in an application, which is connected with some traffic, which is connected to a visit by one of your users, which then call the call center. So it is a knowledge graph. You want to see the phone call, the person, the user, but it's too much data to put it in a single store typically. At the same time, you have business relevant data like transactions, accounts, people sign up multiple times, etc. And ultimately, you also have data outside of your organization. You cannot get this data inside your organization. You have to use services. You have to look up reference data. So that is all part of the knowledge graph, right? So very operational data, more business data, and data that it's referenced and you can get. So if you want to see it as a knowledge graph, I think two important questions you might want to ask yourself is, what kind of edges do you have in this knowledge graph? And what kind of use cases, right? So if you have a shared identifier in this data, like you have a user ID, and the same user ID is here, is here, is here, is here, then that's nice. It's gold, right? Because in a system like Siren, you just connect it and say, that's the user ID in that table in Oracle is the same user ID in this Elasticsearch log. Fantastic. It will look like a graph database you can click. Great. Sometimes you don't have the shared identifier. Sometimes you have Giovanni Tummarello, blah, 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 and in another record you have Giovanni Tumbarello, which is a different address, and the phone number is written differently. But they're the same entity, right? So in a knowledge graph, you want to see it as the same thing. So that's called entity resolution. It's the capability of recognizing the two things in your knowledge graph are not the same because they don't connect immediately, but they should be the same, right? So you need that capability as well, connect things that are not connected with IDs. And sometimes you have text, and you need the ability to extract those entities if you want to create a knowledge graph. So kind of edges, kind of use cases are very important. I mean, what do you want to do with your knowledge graph? Are you looking for fraud? Are you looking for bad guys? For which you might want to just click and see what's connected. So even just putting a user and seeing that it's connected with these emails, with these purchases, across different systems in your organization, that could be gold already, right? So for that, no, you don't need a graph database. But say that you need to, for example, look for, tell me all the users that have made at least this many purchases of products which have been subject to these problems. It's kind of a path traversal, right, in a knowledge graph. But it's a fixed path traversal. It's not a variable path traversal. So it's a bit technical, but basically you can write it as a SQL query. So if you can write it as a SQL query and all your data is already in a database, just fire a SQL query, which is what Siren does. So we can solve these big data fixed path problems without a graph databases because the system will just write SQL queries and they work, right? So even for this kind of use cases, you're good with what you have. But then there are a lot of useful use cases, like for example, in financial, find me certain structures, certain graph patterns, find me the centrality of certain people, for which there is no way that you can do it without a graph database. So in that case, so ask yourself, what is it that I need to do? And then decide which of all this data you need to fit into a graph database. And then use a system that can actually connect to all of them and then leverage the best. In fact, in the demos, I will show you how, for certain use cases, we leverage Neo4j, it's just an example, ask the shortest path, ask for patterns, and then you visualize the logs in Elasticsearch. You visualize the emails in the search engine without really having to load everything inside. Okay, makes sense. I hope it makes sense so far. This is entity resolution, which is this thing about connecting records, which should be connected, but they're not. So it's these capabilities that you need to create a knowledge graph. It's a very, very interesting use case. I will not go into details, but if you look at these records, they have almost nothing in common. They basically 123 Main Street, this is 123 Main Street, this is Bob Smith, but this is Bob Jones, this is Robert Smith, and all of them. But there is a complex logic, and there's a beautiful video if you want to see that if you do a lot of mathematics and reasonings, you actually get to put these all together in a very, very solid way. And that's one of the features that we have. So when you connect with Siren to your backends, you get this thing and you combine them together. It's called entity resolution. It is a real machine learning capability for knowledge graph. And this is how it looks. And I will actually show you a demo on the graph. Here you have a record. This is Hedgeco Invest. And it says, look, has the same address. We have about 12, it knows more than 12 ways of writing different addresses for different nations. It can do it, let alone the number of ways you can write phone numbers and dates. It recognizes how likely it is that certain properties are written wrong or right. Like for example, if you have a Rob Smith and you have another Rob Smith and they're born on the same date, the system is smart enough to tell you it's not enough to actually tell that those people are the same because every day in the US, there is about 10 Robert Smith that are born. So in that case, when you use Robert Smith, because it knows the frequency of Robert and it knows the frequency of Smith, a system that's smart enough will tell you, wait a second, I'm not sure. You see what I mean? And here it's showing you on the graph that these are actually quite likely connected, and it also shows you at a scale 9 million of connections in my knowledge graph. This is telling me that there is 9 million links that have been extracted just because of similarity. And when you have text, told you, right? You have text. There's nothing you can do. You just have your emails and stuff like that. There's nothing, but it's still part of the knowledge graph. You have to have tools that can actually analyze the text and the emails and tell you, what are the entities that are extracted and what are the main topics, all integrated in the same UI. So sometimes you just have to go to that element and go and analyze. This is the analyzer, the automatic topic clustering system that we put in the latest version of Siren 10.3. So leveraging graph databases, this is an example, and I'm showing it to you now because you will see it in the demo in a second. There's a connection of Neo4j, which is this thing we just launched, where you basically write a very complicated Neo4j query to detect bad guys. In this case, this is a use case that's coming from a financial here in London, and they wanted to know, do we have two people that are both directors, and there is two companies? But this one person is executive director in one company and non-executive director in company B. The other person is the opposite, is executive director of company A and non-executive of company B. I'm not an expert, but according to these people, that was a fishy situation, you know, a situation that you want to investigate. Perfect for graph databases. Only graph databases can do things like that. So you basically write your big query, put it in Siren, put a connection to a Neo4j. Neo4j pops up things like that, and they're very sophisticated, and that's actually the circle you're looking for. And then you use all the tool, the link analysis, to investigate exactly the situation. But I'll show it to you in a second. And so it is demo time. You know what? I don't have the time. Like, do I have 10, 15 minutes? Oh, I have it over there. Thank you so much. All right, so let me show it to you. This is what we call the classic demo. We put, let me make it a bit bigger for you guys. Just hope it's reasonable. So we have 4 main tables. So you can connect to a database, Oracle, Postgres, wherever you have. One is about companies, and there is 160,000 companies. Then these companies have received investments, and there is 40,000 investments. And then the investments are made by investors. We have 15,000 investors. The companies are also mentioned in articles, and we have collected 600,000 articles from the web, just web blogs, right? So you can say, well, this is not a knowledge graph. This is, you know, BI, right? It's a dashboard. You can just drill down. And I tell you, wait a second. Look at this. This is new. These 160,000 companies are mentioned in 300,000 articles, and they have secured 40,000 investments. That's the knowledge graph for you. In other words, the system is actually looking at entities. They're not seeing them as just a dashboard, but it's seeing them as entities, and it's showing you what's connected to them. How is this possible? And I can do that. Like, for example, I take any company that contains the word media, for example. I just look for media like a search engine, right? And now, as I drill down, it says, look, it's 12,000 companies, and they have secured 4,000 investments and 50,000 articles. So as you drill down and you put filter and say, well, I just want media companies that are in this very specific region. I don't know if they, you know, you see the numbers changing. So 300 companies, they have received 150 investments. I can click and do this operation called set-to-set navigation, going from a set of companies to the set of investments that those companies have received, right? So these are the 151 investments received by companies in South of Europe, which mention the word media. And then from here, you might say, okay, just show me the investment in the past few years. For example, I put a filter, and then there is 60 investors connected. So I can click, and I go and see the 60 investors. And every time I do this navigation, relational navigation, the relational lineage, so where do I come from, it's preserved. You can always go here in the filter and says, well, these are the 60 investors that have made an investment in the last 3 years in a company in South of Europe, which is mentioned in a query media. Okay, so effectively what you're seeing is the blending of knowledge graph with BI. BI is a single dashboard. You drill down like that. Knowledge graph is, but this is actually knowledge graph navigation at scale. You know those link analysis system, you do click, click on a single node, for example, a single company, and you can see all the investments from the company, right? Now, this is at scale. You can drill down on 160,000 companies and see the 40,000 investments that they have. So you can say, tell me all the companies that you know, talk about this and that, and at the same time, navigate to all their investments, right? So it's knowledge graph navigation at scale. Now, the thing is, how is it possible that the system knew where to go, left, right, etc.? And this is the very cool part. It's so easy to get to this from your existing database. So say that you have your stuff in Oracle. All you have to do really is to map your tables, companies, investments, investors. All you have to do is to map them into this data model editor. This is a data model editor. This is my company table. And so let's actually take a look at the company table. Here, I click on companies. And I can see the company table is connected into a certain backend. This one is in Elasticsearch, but it could be in Postgres or whatever you want. This is the icon. These are the low-level fields. So these are all the fields in my table, you know, CT, category, code, something like this. And then when you get to the other here, ID, you see the company ID. There is this arrows here that are saying this ID is connected somewhere else. Okay, interesting. How do I specify that in the Relations tab? Here in the Relations tabs, you basically edit your connections. So say that the companies, for example, you want to add a new connection. Say, well, I want to get the blog and the blog URL. And you know, the articles, they also have a URL, for example. They're very likely not going to have the same URL, but you know, same blog. You just edit it here, just same blog. So this is the two names. This is basically editing the ontology. So what I'm doing is I'm saying companies have the same blog as the article URL. So if those two values match, even across different backends, then it's a relation. That's how you define it. You save it. Now I go in the data model, and I find a new relation, right? The same blog relation is the one I just created, and the user interface immediately updates. So when I go in the user interface, and I go to, for example, articles, I know that I might find some strange number because sometimes there's nulls, and so so here, no, it actually, sorry, it's a bit too big. Yeah, it's basically you get 0, which is exactly what I was waiting for. So there's basically no company has, you see, you basically get same blog, 0 articles. So it's simply telling me that there is no company that has a blog which is the same as the URL of an article. Of course, I just made a silly relationship, but that's the concept. You basically edit that thing and immediately get the connection to where you want to go, and you can then use that to drill down and ask deeper questions. But there are questions that no dashboard can answer, like which of these investors have invested together. You know, these are the investors that invested in media company in Europe, right? Which of these investors have invested together, and which of these investors have actually, you know, invested in competitors. So for that, you need link analysis, and the system allows you to just simply get, you know, whatever subset, in this case, those investors, and just put them here. You know, now I put the investments. These are the 102 investments they've made in the last 3 years. So I'm just really reusing the filters that I have created before to do link analysis at scale. How scalable? Enormously, because this thing works on the data where it is. So if you connect it to a petabyte data, Elasticsearch, or whatever Oracle you have, this will show all of it. Of course, not at the same time, but first of all, you don't need it at the same time. Second, if you want to see all your data, you just go to the dashboards, because dashboards are made to show you 1 billion records. They have no problem with that. They just send the aggregates. Is their, you know, analytics system are made for that. So it's the combination between the two. So I used, here you have a very interesting way to modify the graph. So now I've you know, put those my analysis here. I reorganize my layout. I can see the big investments are here. You can modify the graph in many very interesting ways. I can do an expansion. For example, let me select this guys and select the expansion. Here you can see, for example, all the relationships that are defined in the data model. So you can select which one you want to expand as. For example, there is a competitor. So I select competitor, I expand, and if any of this has some competitor, yeah, you see, some of them are popping up, then you will see them here. If any of these have a geographical representation, so for example, they have a latitude and longitude, then you can see these guys on a map, see where they are, with the relationships on top. If anything of that has time, and here you have time because there is investments and there is a lot of other things that there's articles as well. So let me expand and see if there is, yeah. So and now I'm expanding. I'm getting the articles that are connected. So there'll be a bunch of articles that are coming out. But articles have time, so it's useful to see this. You can actually see the evolution of the knowledge graph in time. So you can go back in time and then press play and see how this evolved over time. So, George, I'm wrapping up here. Just 2 things I want to say. I've showed you investors, but actually you can use it for a lot of things. In this demo, we are connected to 10 different backends at the same time, including graph databases, Oracle, etc. In this one, this is fake faces, but that's real data about stolen vehicles or something like that. So you can do knowledge graph for looking at, in this case, it's law enforcement. This is life science. I have connected with food and drug events. Here you can see 26 million articles from PubMed. So all the information on PubMed, you run it through natural language processing, and you can get genes, drugs, diseases, and you click on a specific gene, and you see which one are the diseases which are more connected to it, and then you can click and go and see which are the molecules which are mentioned. So same concept of knowledge graph. Now I'm navigating to the molecules, which then are connected to drugs and clinical trials and whatnot. So same concept across different things. This is Thomson Reuters knowledge graph, 5 million companies being able to navigate it, 50 million transactions, being able to spot bad guys on operational transactions. I won't have time to show you this. And if you are in intelligence service and you want to see 500 million simulated phone calls and actually see who they called and who they are connected to, that is also something that you can do. So just turning back to my last slide, George, if I can. I'm keeping you away from lunch, I understand, right? Is that the point? Way too early for lunch, so that's good. So I just wrap it up, right? I introduce the concept of augmented analytics. So analytics is visual. It's about letting an investigator understand what's really happening. There is a really, really interesting paper written about 15 years ago that says the perfect search engine is not enough. What does it mean? They actually did an experiment. People were looking for more information, and they actually gave them an oracle that would give them the best information right away. They never choose that. They always wanted to investigate. They always wanted to drill down and understand how they got to that result. And that's why today in e-commerce you always get a lot of choices. You can drill down by size, by color, until you get what you really want, because people like that. Analytics is about that. It's about understanding why you get that result, not just giving you the results right away. So augmented analytics uses combination of knowledge graph, machine learning, for example, entity resolution, knowledge representation, to advanced analytics. And you can get this on top of existing GraphDBs for certain use cases, but for others, GraphDBs are absolutely unique. So I'm very, very excited now to be working on this, and I'll be pushing GraphDBs as much as needed inside enterprises. Last 14, AI, which is not something we talk very much, but yes, augmented is about AI, is going to be more and more important. The next thing you're going to see in Siren is, for example, lighting up of certain records in the dashboard automatically because they are anomalous. They're different from 20 million of other records. You want to get that information first. It's very important that analytics today doesn't just show you the number, but it also tells you if that number is strange or not. And that's where we are going to be working on. So at the beginning of next year, you're going to see that released. So that's me. Thank you very much.